Creation of a highly efficient wind turbine using wind detection and direction adjustment to optimize wind energy production by George Montague or James Montague. I go by James. Introduction. Commercial wind turbines cost approximately $2 million per megawatt of the wind turbine. The need for renewable energy is increasing with fossil fuel side effects. So we have a really high dependency on fossil fuels, but side effects of all the carbon that's pumped into the atmosphere is causing global warming and all the deforestation and land erosion that's being caused by the mining and drilling is also hurting the biosphere. So a type of renewable energy is wind energy, and wind turbines is a primary form of wind energy. Wind turbines do have problems though, and one of them is that they're only operational 30% to 60% of the time. And so this is because they can only operate when the wind is perpendicular to the direction the blades are pointing. And so depending on what the wind patterns are and where they are, it kind of varies from this range, but generally wind turbines that are on land are close to 30%, and wind turbines that are in the ocean are closer to 60% because it's easier to predict the wind currents there. And there's more laminar flows. Then a seal, which is the part of the top that contains the blades in the generator, on a commercial turbine can rotate. However, it can only rotate manually. So there's a motor there, but it doesn't automatically rotate. Someone would have to go up to the top and physically rotate it themselves by pushing a button. And then usually there's not just one wind turbine, it's a wind turbine farm. And they're placed in many different directions all over the place. That's because the wind direction changes and they always want to be producing energy. So, maybe there'd be 4 or 5 going each direction in a wind farm of 50 wind turbines. So at any given time, 20% of the wind turbines are producing energy. So, in order to do that, that makes them a lot less cost effective and also a lot less successful. We need to buy so many of these to produce a decent amount of energy. So my research question was, how would the efficiency of wind energy be affected by a wind turbine that adapts to and faces wind? And my hypothesis from that wind turbines will be efficient, or more efficient that is, produce more energy and therefore be more cost effective by rotating to face the wind due to being able to produce energy at a greater proportion of the time that they're operational. So this is my method. I don't actually have an operational wind turbine at the moment because I'm having some problems with the programming and setting it to receive the data from the anemometer that collects the wind direction and then actually rotating it. But this is the method I've set up so far and that I'll continue to use to finish my turbine hopefully in the near future. So each component of the turbine is made up of different materials. There is some overlap between the different components, but they're generally in 3 groups. So then the seal, which is the top that houses the generator, is made of sheet metal aluminum sheets of 0.1 inch. And it houses a 24-volt, 350-watt electric generator, which connects by an axle to a 3-blade fan. Essentially, that's what it is, because it's a mini generator. And then that connects to the tower, which is kind of like the stock part of it. And the connection is actually a motorized ball bearing, so it can rotate on top to face the wind. And the tower itself is made out of a 5-foot tall PVC pipe with a 4-inch diameter. And that houses both the DC motor that motorizes the ball bearings and also the control Arduino, which collects the data from the generator to see how much energy it's producing. And then also sends commands or receives data from the anemometer and then sends and then kind of calculates if it needs to rotate, if it does, how much, and then sends that to the motor and adjusts accordingly. And then on the bottom half, the tower connects to a base, and the base is just essentially a large OSB board that weighs 50 pounds. And so it just really anchors and secures the turbine to the floor and makes sure that nothing is unstable in that, it's not going to come crashing down and break everything. And on the top of the seal, there's also an anemometer that receives the changes in wind direction and also measures the speed, but that's not currently being used. But it measures the wind direction changes and then to the Arduino. This is a diagram what I just explained. So you can kind of imagine that the red part is on the base is the OSB board, connects to the tower. The tower connects by a motorized ball bearing right here to there you go. So this is the OSB baseboard. You've got the tower right here, connects by the motorized ball bearings. This is the generator. This is the gears to get the accessible speed for the generator. You've got the 3-blade display right here, and you've got the anemometer right here. This is the kind of very basic display, but kind of shows what I'm trying to do. And it's modeled off the shape of a wind turbine because that's kind of the application I'm trying to explore here. So obviously my original plan was to do 2 4-week studies, one as with a control where there was no rotation, it was just locked in a certain direction, and another one for the 4-week one where it would rotate and then see if there is a significant difference between the levels of energy that were produced. But timing, I was unable to get that finished in time for this, and so I had to look at other literature and kind of and predict what the results would be for this. So for what I expect from other research and literature that's been published is that a rotating wind turbine would increase the energy produced by several factors. And this is because it would increase the proportion of time that the energy is produced. So if it's turning to face the wind, and if the wind is perpendicular more often to the turbine, it's spinning more often and it's producing energy more often. And so that's going to increase energy levels. So the rotating will increase the cost unit production. And no matter if it's like, a 1 megawatt or a 12 megawatt wind turbine, they're all going to increase in price. No matter what you do, if it's a brand new turbine, it's going to cost more, or if it's just an upgrade so that it rotates itself. If an existing wind turbine, it's still going to cost more. However, it will become more cost effective because the cost may go up by say 10, 20%. But if you need, a third of the wind turbines after that to produce the same amount of energy, then your overall cost is still going to drop dramatically. So what is the impact and importance of this? So the biggest thing here is it's making wind turbines more efficient, which would allow greater dependability on wind energy. And this is crucial for fossil fuels, because if we're able to, depend more on fossil fuels and say use 40% of our energy from renewable energy, then we can phase out of fossil fuels and kind of break that carbon cycle, or break the addition carbon cycle. And not only that, but fewer turbines need to be purchased, so wind energy would be more accessible. So not only is it more efficient for the turbines we already have, but then we're able to have more turbines because factories, it's more achievable for a small factory to be powered by wind turbine. For small villages, be powered by turbines, they're cheaper. Or if you need to buy fewer of them to power houses and stuff, because right now a turbine can only produce energy, or the most common is a 2 megawatt turbine, and that can only produce enough power for about 450 houses. If it's 5,000 houses and it's only 3 turbines, that powers a small town or even a small city. So it's a lot more accessible. And because of this, less land can produce more energy. So not only does less land have to be devoted for turbines and more can be used for agriculture and other things, but also there's less deforestation and other negative effects on the biosphere. So it's really, really important to develop this wind technology, because then we can, use less fossil fuels, then also kind of conserve land, conserve trees and stop deforestation, and also make wind power easier for everyone to use. So this is my bibliography, and thank you for watching this.